The first thing we're looking for in this problem is the molarity of nitrogen gas in the blood at 1 atmosphere and 4 atmospheres. So we use Henry's law, which is the concentration of dissolved gas in moles per liter, equals the gas constant, which for nitrogen is 3.8 times 10 to the negative 4, and the pressure. So we calculated at 1 atmosphere and 4 atmospheres, so we plug in the constant and the atmosphere, so 1 and 4, and then we get these answers. So we have these in moles per liter, so the concentration at 1 atmosphere is 3.8 times 10 to the negative 4 moles per liter, and at 4 atmospheres the nitrogen concentration is 0.00152 moles per liter. So we have these in moles per 1 liter, but we have 5 liters of blood, so we want to multiply it by 5, and that will give us the moles at 1 atmosphere and 4 atmosphere for 5 liters of blood. So that's at 1 atmosphere it's 0.0019 moles, and at 4 atmospheres it's 0.0076 moles. We want to find the volume of nitrogen gas released from 5 liters of blood, so we take the amount at 4 atmospheres and then subtract the amount at 1 atmosphere. So we plug in these numbers, so then we have 0.0076 moles of nitrogen gas minus 0.0019 moles nitrogen gas, so that gives us the moles of nitrogen gas released from 5 liters of blood. We want to turn the moles into liters, so we use PV equals nRT and we plug in what we know, so we have 1 atmosphere times the volume, which is what we're looking for, and then we plug in the 0.0057 moles of nitrogen gas released from 5 liters of blood. And we have the gas constant, 0.0821 liters times atmospheres over moles per Kelvin, and we multiply that by 310.15 Kelvin because that's 37 degrees Celsius from the problem. Then we get the volume of nitrogen gas released is 0.1451 liters. We want to know how many bubbles fit in that. This is the total amount of nitrogen gas released, but we want to know how many bubbles fit in that. So we find the volume of 1 bubble. So to do that, we use the volume of a sphere, which is 4/3 pi r cubed. And we know from the problem that the diameter of a bubble is 1 millimeter, so the radius is 0.5 millimeters. We plug that in and we get this answer, which is 0.5235 millimeters cubed, but we don't want to leave it in millimeters cubed because we want to be able to compare it to volume. That'll make things easier. So then we do this conversion, and when it comes out as liters, it's 5.24 times 10 to the negative 7 liters. That's in 1 bubble. Now we can find out the number of bubbles in the volume of gas that was released. We take the total volume of nitrogen gas and we divide it by the size of 1 bubble. So we plug in these numbers that we calculated. So you have 0.1451 liters of nitrogen gas divided by 5.24 times 10 to the negative 7 liters for 1 nitrogen bubble. So we get 276,908 bubbles released from 5 liters of blood. But if you wanted the bubbles per 1 liter of blood, you can just divide this number by 5. So you do 276,908 bubbles divided by 5 liters. That gives you 55,381.6 bubbles in 1 liter.